presentations yesterday and interacting with people is the excitement about this work, the real passion and wanting to know more about how students learn and how we can foster more and deeper learning. And the excitement, the enthusiasm is just marvelous. Of course, it's a lot of work because it's a new discipline for everybody, or almost everybody.
Okay, good morning. Actually, I'm looking into communication skills development in engineering education. So I would like to look into how much the engineering students have managed to develop one of the learning outcomes or the learning attributes of communication skills, and whether I would like to introduce an assessment model, actually, assessment method of how to assess communication in the engineering education. So my main focus is actually on the final year project of the students, the capstone design. So through the capstone design, I would like to see whether they have managed to develop the communication skills or whether it has been properly implemented and applied throughout and also I would like to assess as to whether these communication skills have been developed throughout their undergraduate studies. So my focus is actually on assessment of the communication skills, which is one of the attributes, the international attributes, which is emphasized by AVAT, IEEE, and also some of the accreditation standards. So I'd like to compare.
So wonderfully clear, articulate elaboration on your interest. What got you interested in exploring those areas?
So actually, my major is actually on English, TESOL, but because the current trend now is on engineering and multidisciplinary, so that's why I plan to focus on this, and was also, my supervisors has managed to.
All right, so you got some support from your supervisors.
Okay.
Great, great. Thank you. And so, again, the climate here seems to be one where there's more encouragement, there's more support for systematic work in this area, and it's growing in the U.S. and in other countries too. It's still seen as unusual, I think, in many institutions. This doesn't look exactly like technical research in a technical discipline, but given the concerns and the needs for educating people in very different ways, to work in different ways internationally. I'm impressed by your logo now. What is it? Innovative and creative minds or something. So you've embraced this idea. We have to prepare graduates to do things differently. And that means it has to happen in your classes, in your laboratories, in your recitations, if you're going to prepare people to work in different ways. And so I think preparing a different kind of graduate and really understanding what it is that makes a difference, how these communication skills develop, what we can do to foster them, how we know, what evidence we need, the assessment piece that you mentioned is very important. Just a couple reasons that we're seeing, mainly in the U.S., but I think they're probably common in other places, why we might want to be interested in this area. One of the things we're seeing is many calls for what's called evidence-based teaching practices. So, it's really, show me the evidence. Why are you doing what you're doing? What support do you have for the notion that idea will make a difference? And here too, it's showing up in the popular literature in the U.S. This is Science magazine, but I guess that's really an international magazine. Very prestigious, high impact factor journal. And they're they're continuing to publish articles in education. This is one from Eric Mazur. Eric Mazur is a physics professor at Harvard who has developed, he calls it peer instruction. It's essentially an informal cooperative learning strategy. So he teaches through questioning rather than through presentation. And he titled this article, Farewell Lecture, Goodbye Lecture. Now he poses questions for the students, they respond. He makes decisions based on how well they seem to understand and are able to explain. So he doesn't tell them what they already know. He works in ways that helps them learn things that they don't know. Another model that's become quite, well, I mean, it's not pervasive, but it's becoming much more common is what's called the scale-up program. It's a small group approach, typically 120 students, all seated at round tables in teams of 3, entirely problem-driven. And I know that here there's quite a lot of interest in problem-based learning, but it's a way of doing problem-based learning in a very large class setting. At MIT, they call it the TEAL model, Technology-Enabled Active Learning. And this is an article, a couple of months ago from the New York Times. Again, a very popular, major news source. And again, we're seeing more and more of these calls for research-based, evidence-based teaching and learning strategies. And a lot of these were developed in other settings. K-12, or pre-college, have done quite a lot more work in this area than we have in post-secondary. There's even less work in graduate programs. But again, I think more and more, now that we're, at least in the U.S., we're in a real resource scarcity era, there will be more and more demands for using practices that you can argue are demonstrated to be effective. We know that this will make a difference for students. Another reason that we're seeing is many faculty want to bring a more scholarly approach to teaching and learning. What we've seen from many PhD graduates is they just do what their professors did. And this is commonly called distal pedagogy. Teaching with your back to the students. You've all seen that. It's commonly called teach as taught. And we can do better than that. I'm quite confident that there won't be a really large group of people who make engineering education or educational research in their discipline, if it's science, physics, chemistry, biology, mathematics, etc., that there will only be a small group of people who make that their principal research area. And it's folks like the ones here at UTM in the engineering education PhD program. They're really positioning themselves to do engineering education research as the main part of their research portfolio. What we would like to see is many more people become more effective teachers. Use best practices. And then over time, we'd like people to bring a more scholarly approach, to do some systematic assessment, make continual improvements, make it part of their annual performance plan, that they're going to spend some time making systematic improvements in courses that they teach. Those who then take that work public and present it in conferences and seminars and other settings, that's in the U.S. and I think around the world, it's called SOTL, the Scholarship of Teaching and Learning. It may not be, funded research. It may or may not be published in archival journals, but it's really bringing a very scholarly approach to teaching and learning. And I think more and more, as we see these calls for more evidence-based practices, more and more of us are going to need to move to a more scholarly approach to teaching and learning. Just like we do in our technical disciplines. We're familiar with the literature. We have some familiarity with the prevailing theoretical frameworks. We talk with our colleagues about the work. We do systematic assessment. And we're seeing a lot of interest in moving from teach as taught to a more scholarly approach. And then again, this is the group that I'm mostly working with right now, especially PhD students who are really trying to make this their principal research.